Alright guys, so I figured I'd do a little bit of an explanation on how I have the boost control set up on my Terminator X, and it seems to be working extremely well. So first off, we have the boost individual configuration file right here, and this is how everything's kind of set up to run if you wanted to run the boost control system in the Terminator. And so I have a dual port dome pressure control, single Holley 3-port dome pressure only, operating mode boost versus speed. And I got trans-brake launch input enabled for launch target being 8 pounds of boost, boost scramble 4 pounds of boost, and so on. So and here's the basic, obviously too. Here's the basic safety setup. Above 24 psi, cut ignition, boost pressure above 20 psi for 2 seconds, revert to wastegate. What that'll do is just shut off the boost solenoid and cut the overboost. However, this one here, the revert to wastegate, does not work with the way I got it set up, and you'll see here in a little bit why. Another thing I want to explain, the TPS boost modulation. That's throttle position sensor based boost modulation. So if, let's say you're at half throttle, and let's just say at full throttle you got a commanding, well, let's just take a look here, boost versus speed. I'm commanding 12 pounds of boost at full throttle. If I back the throttle down to 50%, it'll only command 6 pounds of boost, if that makes sense. And you have to be above 50% TPS for it to start working. Obviously, once you go below 50, I'm actually not entirely sure what it does at that point, but this is how it, I haven't played with it enough to know exactly. Maybe somebody can answer that in the comments section or something. But anyways, so yes, dome pressure control, blah, 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 you can fill all this out, but really all of this is irrelevant for the way that I do it, because I use this just for your boost versus speed. So at 0 miles an hour, we're at 8 pounds because my launch target is 8 pounds. So you want to start at whatever your launch target is, and then of course you can put the mile per hour, you can type it in however you want in here, and then your boost for that mile per hour. Now this is dome pressure, and this just doesn't seem like it would work, but it does. In my data logs, my dome pressure mimics the desired boost level, and this is why I'm talking about desired boost level. If you go to inputs and outputs, you'll go to outputs, and what I want you guys to do is make a custom output called wastegate, or you can name it whatever you want. Type is a pulse width modulation because we're going to be using one of those MAC 3-port solenoids. And then we go to configure. And what I did here is I have switched input trigger 0 and sensor input trigger 1. Manifold air pressure is above 107 kPa. Let me change that to PSI. In case you guys didn't know how to switch from kPa to PSI, it's under Toolbox, Preferences, Display Map as PSI. For me, that's a little easier. So 1 PSI. And this is boost because you can go here to negative. That's vacuum. So basically, we're going to go into boost. I have it come in at 1 pound of boost. It starts to activate this pulse width modulated output, and it deactivates it when it gets down to 0.1 pound of boost. So basically when you go under boost, then that way when you're in vacuum it will never be activated, or else the pulse width modulation, the solenoid will be sitting there trying to run in the background the whole time. Linked outputs, none. Timer, none. Don't do any of that. So here on the pulse width modulation setup, you have fixed the type, and you have frequency at 18. 18 seems to be a good roundabout number for a 3-port MAC solenoid. The 4-port, I've been told, is closer. You want to run around 21, 22, something like that, or even higher, I think. I can't say that off the top of my head right now exactly what the number is, but it is a little different. But this setup here is basically set up for a 3-port. We're going to go, the table unit's going to be duty cycle. That's what's inside this table. And then you have RPM axis over here on your bottom, going left to right. And your target boost axis going on the side up and down. So the way I got this set up, my 2-step is at 3,000 RPM. So at 3,000 RPM, if the boost is below 6 pounds of boost, I have it at 80% duty cycle going to this boost solenoid. What that'll do is send full pressure, or I guess 80% duty cycle, which is almost full flow on the MAC valve, send that pressure to the top of the gate in order to close it and continue building boost. The reason I didn't do it at 6 is because I was thinking I might end up wanting to launch on 6 and not 8 pounds of boost. So I didn't do that yet, and I haven't tested this yet to see if it'll build boost fast here and start to drop. It's something you got to play around with on your own vehicle. But anyway, I went out and tested it, and around 10 pounds of boost, I need about 47% duty cycle on my solenoid. Like basically, if my solenoid is running 47%, my actual boost is 10 pounds. If my solenoid is running 75%, my actual boost is 22 pounds of boost. And so once you know those numbers, you can fill this table out. And this is the target boost. Remember back here under the boost and the boost versus speed, this is dome pressure. And just remember the dome pressure mimics the target boost. So whatever we put in here, let's say if we put 12 psi in here, that is our target boost. And that makes it a lot easier so that you can actually use this system. So now if you go back to your input or your output over here, pulse width modulation. So if I'm commanding 12 pounds of boost, my my solenoid is going to be running at 51.8% duty cycle, and therefore I'm actually going to get 12 pounds of boost. And the reason I prefer this table to do target boost over here is so that if I hit the scramble button, I want to add 4 pounds of boost, it will actually jump up from 12 to 16, and the duty cycle will go up to 61, and therefore give me my extra boost. That way, I get all the benefits of running this system, but not running the PID controller, the closed loop system. I can just, there won't be any overshooting, undershooting, or correction. So, I mean, if you can get this system to work good, the PID system to work good on yours, then more power to you. I just couldn't get mine to work, and I've tried different settings. This is the last settings I tried, and I just couldn't get it to do what I wanted it to do. So I'm sure that I can with enough time, but I also kind of like the simplicity of that other setup. So anyway, that's how I did it. I don't know. If you guys are interested, try it yourself and give me some feedback, see how it works for you guys. But it works pretty darn good on mine. I've been really happy with its setup, or how it's been working. So, and like I said, this 80%, you'll just want that in an area where you're trying to build boost. So, yep. You got any questions? Leave comments, or I'll try to answer them. Maybe make a follow-up video if I need to. Just let me know. Thanks.